Thank you. Assalamualaikum warahmatullahi wabarakatuh. Thanks, Dr. Dina. Hopefully my voice can be heard everywhere. Is
Yes,
it okay,
loud and
Dr. Dina?
clear.
Yeah, thank you.
Yes, loud and
And
clear.
also, and first of all, to thank the organizer for inviting me again, and welcome all Datuk Seri Zohari bin Haji Yaakob, President Malaysian Association of Facility Management, MAFAM. And we have also our Tuan In Senior Dr. Muhammad Fazli as our chairman, inviting to me tomorrow. And of course, today we have Encik Shah. Thank you for inviting me for today for the session this morning. So how I can share my screen, Doctor?
You can at the below your on your screen,
Yeah,
there's
yeah, yeah. Okay, now
share screen.
shareable. Now shareable. Okay, okay. Before this
Yeah.
cannot, huh?
Oh, okay.
Okay, okay. Thank you so much. All right. So let me set all this thing first, huh? And again, I would like to um I mean, okay. Is it okay now? Is it all clear? Clear for all the screens? Okay, Dr. Dina?
Yes, we can see that.
Okay, all right, thank you. Okay, thank you again, Encik Muhammad Shahrizal, also Datuk President just now, and also Dr. Dina, and all participants and members during the session today. I was informed that we have a session through this so-called webinar, and we got also physical event there in Johor. I'm not able to be there for these 3 days, and I got another engagement for today. And our topic today is passive building design for energy efficiency strategies in implementing ESG. I'll try to bring this topic. Time given for me about 1 hour, isn't it, Dr. Dina?
Yes,
About
allowed.
1 hour. All right, thank you so much. All right, okay. So here, the topic again, just to introduce or to give an insight of what is actually the, first of all, we need to talk about the passive building design, and particularly to focus on energy efficiency. But our main topic, or I mean main theme today, is really regarding the ESG. So what is ESG? So this is a quite standard definition coming from, if you can Google the ESG, this is what actually we will get. So one of it is actually the green building design and operation, climate risk mitigation. That topic related today, we can talk about, let's say, energy efficiency, water conservation, emission reductions, and also waste reduction. So this is all related to environmental issues regarding the operating of buildings, not only operate, but including of construction of the building. So environmental impact due to the um, due to the energy efficiency is very, very important and very remarkable in our building condition. So the topic today to talk about lighting, heating, cooling related to the building operational. Of course, we don't talk about water saving too much because this is related to energy efficiency, but we can see from the chart here, it's talking about all factors related to the environmental issues. One thing that we need to understand also, how about the things related to our climate condition here in tropical climate particularly, and maybe we have also participants coming from foreign countries that will be implemented by their own condition in terms of the environmental condition over there. So the climatic also played the important role in terms of designing the best implementation towards the energy efficient building by using this ESG templating. So first of all, let us to see few, if we can uh, Google what is actually the passive design strategies means. So this is the definition by Google, but of course it's very, very close to the actual definition in the textbooks. We are referring into strategies, a set of design approaches, a set. I mean to say that we have to have a set of design approaches, not individual, not isolated. It need to be a comprehensive design, starting from the planning, in fact, starting from the mindset of the building owner. If we want to have the things change, the mindset of the building owner, the building funder need to be changed too. So a set of design approaches. So the keywords here is actually a set, because with the correct mindset regarding the passive design strategies, we will try to implement everything that we could in delivering our building design strategies into the energy efficient way. Focus on utilizing the natural environment. Focus on utilizing. So we need to say that we want to have a focus on what is actually our closest environment. What do we have here in our tropical climatic, for example? What is the parameter that do we have in terms of the heat, temperature, wind speed, maybe solar radiation and whatnot. So from there, we implement into the building design. And of course, operationally also, we will look into it. Provide heating, one of the main element, or cooling. Actually, it's a bag of heating, it's a cooling, a ventilation, and of course, the lighting into the building. So unlike active design, so the contra word of passive design is actually the active design. So active design rely on the mechanical system to process, mechanical and electrical system to process. Passive design depend on the laws of the nature. So we want to have a building that we understand is a set of what we call the approaches to implement the energy efficiency through whatever closest environment that we have outside of the building. So building, we understand as a building science engineers, or you are maybe background on engineering or building science or surveyor or anything that related to construction or building maintenance, we understand that building has their own envelope. So we name it as a building envelope. It's actually walls and all those roofing and all, I mean, window and doors. So what is actually outside that envelope to be implementing? Is that possibly carry out in our building, construction as well as the operation to implement these strategies in our building? So they have few pictures to give of basic insights regarding these passive design strategies. For the top one, we're talking about the cross ventilation from one side to another, and how it can be very useful to cooling our interior, and to cool our interior and to make the air change very presence. Some of the building we cannot have that air change from one to another to be very what we call efficient. So they will create another building problem. That's what we call a building, sometimes sick building syndrome. They're related to building sickness. And also in the lower part is talking about still the ventilation, how we want to use the ventilation roof space to minimize temperature differential across bulk ceiling installation, for example, reflective foil, and all those strategies that we can implement, or put the thermal mass for closed storage, for example. All those strategies can be implemented. Sometimes some of them are very cheap in terms of making it happen. Of course, some of them we need to put an additional cost. So, but if we have the mindset from our perspective of building users or building owners, so they can be implemented as much earlier. So this is as an overview of the topic that we are going to talk today. And of course, I'm referring lots of our material from these documents, MS 1525, energy efficiency and use of renewable energy for non-residential building, Code of Practice, third revision. Because why? Why we need to have a passive design? Because a passive design building use strategies that maximize energy efficiency and maintain the human comfort. So we've got two main important keywords here. We talk about energy efficient, and of course, we need to talk about the human comfort at the same time. The key to the strategy is to maximize the energy that is gained and minimize the energy that is lost. So the main reference of this topic is actually this 1525. The book actually you can download. This is actually also, I'm sure that many of us also referring of the book if we are working in the FM industry or construction industry. Okay, so we will talk about these two more on the energy efficiency and also the human comfort. So talking about the human comfort and indoor environment, perception about the indoor environment is closely linked to their health, well-being, and productivity. There's research made to prove that the human comfort in the building will be very, very much significant into the health, well-being, and also productivity of our occupants or us as a building users. Improvement of comfort level in a building has significant positive impact on occupants. Human comfort in indoor environment can be assessed in two. We got two comfort zone minimum. They actually many. We can put 4, 5. Some books refer to 5, some books refer to 3 and 4. But I will just to focus in these two because the topic related to EE today: thermal comfort and also visual comfort. Thermal comforts taking into account a range of environmental, work-related, and personal factors when deciding that makes a comfortable workplace temperature. So we want to make our temperature or our workplace temperature close to human comfort. So human comfort also sometimes very, very what you call that ranges, because it's depend on that human activities. Human sometimes my comfort maybe about 23 degrees C with aircon, and maybe 27 degrees C without an aircon. So other person might have different comfort zone, but we need to be as close as possible to a majority so that some of the minority discomfort can be adjusted through during that work related and also personal factors deciding what makes a comfortable workplace temperature. So what is the comfortable workplace temperature? There are many research and many guidelines also talking about this. So no problem to have what is actually the comfortable zone when we talk about the thermal comfort inside the building. Meanwhile, the visual comfort is characterized by a sufficient amount of natural lights and also the artificial lights, good glare control, and access to view of the outdoors. So three main criteria when we want to talk about the visual comfort. First of all, is there any natural light inside the building? Because natural light brings sometimes very close to the environment. We will be more, productive when we have this kind of natural lights. And also there is many research talking about the vitamin D in the sun, lights and all those. So that is also contributing into our human well-being and wellness. So natural light, and also we need to include these artificial lights too, because artificial light also play the important role when we don't have access to the direct sunlight, or the direct sunlight is not meet to our minimum comfort. So we need to add on these artificial lights in terms of getting the comfort zone back to the normal. And also good glare control. So excessive brightness also not so comfortable. And also we know that natural lights from the sun or from the outdoor will come into minimum 3 main components. They are the light itself, the intensity of the light, talking about the solar, talking about the lux level or the illumination level. So we can talk about 20,000 or 30,000 lux level in illumination level if we measure through the lux meter. And it also comes with solar radiation, that the heats also come through that. Solar radiation is second component. We can measure through the pyranometer, and that will also we can conclude how much the intensity of the radiation that can convertible into the DC through our solar panel, for example. And the third one, of course, these 3 elements will come through heat as well. Other than that, of course, we got the UV lights, all those spectrum of lights, and all science behind that sunlight. But we want to talk about comfort natural lights. So we need to control the glare. The glare need to be controlled through that. So there is many options how to control the glare from the sunlight, for example. And of course, we also want to access to the view to the outdoors. So there is 3 main items when we talk about visual comfort. So it's not that comfortable if we just work in the cubicle, for example. There is no outdoor views, there is no sunlight, there is no there is a very high glare or brightness. So it will be create more comfortable in terms of our visual comfort. So this human comfort, just when we talk about these 2 only, besides we have many, of course, we have many, but this 2 is very important regarding to our topic today. And also thermal comfort and visual comfort is instantly we can detect. If we don't have that comfort, instantly we can detect that we don't have that comfort zone regarding the thermal and visual. We enter a building, is it, for example, is a totally dark, for example. So our visual comfort is collapsed already. So when we talk about, we enter a building or enter a room, it's very hot. The heat is everywhere. We cannot bear in terms of there is no comfort there. So it's instantly we can detect that we are not comfortable in that room. So this kind of assessment been carried out by many researchers. I believe our distinguished researchers also in this conference, 3 days conference, so partly involved in this kind of assessment or this kind of work. So I believe they will share a good, what we call that, insights coming from the research about this topic. Okay. Then we need to understand what is actually the tropical climate, because the tropical climatic plays their role actually to influence us in how we are making our own design. So there is also I mean the definition from Wikipedia. A tropical climate is the first of the 5 major climate groups in the Köppen climate classification, identified by a letter A. So they start with A, AF, AM, AS, and AW, related to the kind of the tropical that we have. Because even we talk about the tropical climatic, each and individual tropical climatic also have their own some specific characteristic or criteria which is not have in other tropical climatic condition. Tropical climates are defined by a monthly average temperature from 18 to 18 is a or higher in the coolest month, and feature hot temperature all year round, like what we have now in Malaysia. And in fact, in the last 1 or 2 months, we are very having a high temperature. We can reach to about 40, 41, 42 degrees C here in Malaysia. Annual precipitation is about often abundant. We have a lot of rains, tropical climates, and show a seasonal rhythm, but may have seasonal dryness to varying degrees too. There are normally only 2 seasons in tropical climate. We got this wet, which is musim tengkujuh, rainy or monsoon season, and also a dry season. And not typically somewhere in this month, starting from February, March, April, May, is still considered as a dry season. So we have a little bit of raining situation in this time of duration. And the temperature range at tropical climate normally very small. Sunlight is intense. Is this climate? Sunlight is so intense. So we understand that our tropical climate is actually at the median or the equatorial line in the globe, so that we have direct exposed to the sunlight straight away, and then therefore contributing factors to getting this intense and in terms of this sunlight. So back in maybe 100 years ago, 1920, the house that we've been construct at that particular point of time. So we have this kind of houses where we lift it up and let the floor or the cross ventilation. Even in that 100 years time back, we don't have that science to measure what is actually we are doing there at that particular of time. Our of course our generations earlier than us, but they understand the nature and they work with it. They understand the nature, they work with it. Some of the reason to have this cross ventilation, of course, they have many other reasons, because they are working in they have that purpose to have this kind of lifted house. We have we escalate. We put a platform, and then we have some activities underneath the house. So this is an example on how they use at that particular point of time the cross ventilation to make themselves comfortable without knowing the science behind it. They just know if you build this way, we can get more air movement, and therefore we can get more cooling. There's no cooling active active devices at that point. We don't have fans, we don't have aircon, for example. So they just use their own natural creativeness to create this kind of design. So you can see also they are using the pitch roof. Of course, they got they got a very good reason behind it, because they will collect all those heat inside the pitch roof and release it through the louver that we have over there. So this basic design and basic understanding actually was there, starting from, I mean, close to 150 years ago. So like we can see about it on the previous design of our houses. And then this is close up for one of the houses. You can see how it been. This is actually a modern pictures, yeah, with the maybe a quite old house. We can see this. So this is how we put it, and we can see at the back there they started to construct current practice, because we have aircon to correct that part of heating, for example. So other than that, it's still attached to the original building, and the second part is clearly just constructed maybe less than 20 years ago. So this is what we can see from our previous generation, who they can make our environmental as their part of their strategies in making their comfort at that point of time. Of course, now we have more, I mean, what we call it, more technologies, research, science, and all those features to be add on. But when we talk about that particular of time, this is something that very remarkable achievement for our generations, our previous generation before. Huh? So this is an image from the Mr. M.S. Sulaiman over here. There also a paper I put there, the link so that you can download. So don't worry about the slide. There is also a QR code later at late of the slide for you to download the actual slide, so you can use by your own purpose lah. So this is the typical design. We talk about the front stairs. So where everybody coming from this area and a ladder come to the first veranda. So this is where the meeting always been conducted for those coming. They welcoming people over here, and then they got main hall for their families, and also rooms, and then go back to the normally dapur kitchens, and there is also a floor. I mean the stairs to go back, and normally at that point of time, our toilet also at the back of the house. So this is the example of how they use the understanding while understand the behavior of our environment, and then put it into the design, so that we can use the design as what they comfort in that point of time. So, okay, there is some background to understand what it's actually talking about, the human comfort, talking about the home design. So now, this is the current chart regarding the what we call that, the comfort zone. When we talk that about the green area here, this is what we want to know. This is what we want to achieve. Actually, this is what we want to achieve: the relative humidity from 20 up to 80, and then the temperature is between 20 to 27 is considered comfort. Other than that, we need to go for passive devices. For example, starting from by color here, passive solar heating. We need the passive solar heating when we have this. Okay. When we have this passive solar heating, and also we have the red one, we need to go for the cooling, cooling condition. So stop a while because I need to answer this call, very short one. Okay, sorry for that. Okay, so this is the what we call it, the criteria on reaching out the condition that we want. I mean, talking about the passive design in terms of cooling, this is the condition that we can use this chart to understand what is our target in getting the temperature and humidity to make sure our comfort zone is achieved. So we're talking about first, and also the second one, permissible. Other than that is we need to add on the devices in terms of passive device to interact with the condition, so that we can have we can get back the comfort by adding on the active devices. Okay, let me close this one too. Okay, evaporative heat exchange, direct evaporative cooling, for example. So here, what we can see is actually how we can use the, for example, water pond and also the vegetation to cool, to have a cool air coming into our building or our house. And then it will be transmit through whatever opening that we have inside the building, particularly at the roof side. The cool breeze air coming in, and then hot air will be going up. So this is the sample of how we can reach to the passive design inside the building through the evaporation, through water pond, or even the vegetation. So very simple approaches and very yet effective. Okay. Next one. Passive cooling also talking about how we want to implement the segment of the buildings and then put it into a visual. There we can have these ventilations everywhere coming through these windows, going up through ventilation, stack ventilation, going out of the environment back. So things like this can be assessed, can be measured, and also can be designed. We have many simulation to do this part nowadays too. Okay, a glare control. So of course, we want to have a good control in terms of glare. Things like bounce effect from the sunlight, it will affect our own comfort too. So this is how the things happen. We will discuss about how to mitigate it in this slide session today. So this glare interruptions in terms of the building comfort. Now, glare from the artificial light, also same thing. So our artificial light is so excessively bright, so we cannot deal with it. Our eyes cannot deal with it too. So that is where we need to use the science behind it on how we can minimize the things. Okay. We know about the recommendation for the good practice and renewable energy applications are classified under the following areas. Maximizing passive solar design. So we got four main strategies on how we can make use of our closest environmental to our building. For example, we have to maximize our passive solar design, optimize passive cooling strategies, optimize environmental cooling through natural means such as vegetation, set plan, landscape, and shading, maximize the capture of renewable energy resources for solar heating, electricity, solar lighting, and whatnot. So the recommendation for the good practice in renewable energy applications inside the building, we can classify into these four. Even though some of the RE also will be contributed into this ESG principle at the same time. The requirement for EE, meanwhile, are classified under the following areas. So the first of all, we talk about the recommendation on RE. This one is recommendation or requirement on EE, energy efficiency. Classified under these following areas. Design and efficient lighting system. Because according to the research, about 80 to 90% of the building occupants need to, not only building, like whatever the building users need to switch on the lights during daytime too. 80 to 90%. So there is a lot of energy can be used. So if you can have a very efficient lighting system, this thing can be minimized. Minimize losses in electrical power distribution equipment. Losses in electrical power distribution equipment. So there is losses in terms of the copper loss, efficiency loss, power factor loss. All those kind of losses need to be minimized as well. Design an efficient aircon and mechanical ventilation, because we just put the aircon there. We don't realize on how to make it efficient. And secondly, go back to the users also. The users also need to be very, very, wise enough to use how the aircon to be used. Design a good energy management system also can be used or can be monitored through our own. There's a lot of softwares, there's a lot of programs is selling to monitor our energy management system. They have a dashboard to monitor all those. So requirement for this EE is actually mentioned in this book as a classified under the following areas. Okay, then we go back to the sustainable design approaches. We talk about the architectural and also passive design strategies. Design within the contextual climate and site at the first step to optimize the benefit provided by the specific environment. So first of all, we need to understand what is the specific environment that do we have at that particular area. So for example, here in Malaysia, from Perlis maybe to KK, to Kota Kinabalu, from Perlis to Sabah, what we can see from the specific nearest environment there. So design based on this contextual climate. The context of the climate that we have deal on how we can put it into our design. Design solutions shall strive into the achieve energy efficiency and to use environmentally friendly material of higher quality and durable in order to decrease waste. So waste in these terms is really the electrical wastages lah. Electrical wastages come to the inefficiency of any of our devices that we put inside the building. This is actually a combined architectural, engineering, site planning, and also landscape. It's a holistic approach to design and efficient energy building would optimize the energy efficiency of building, essentially we employ the combined passive and active devices. So what we want to do now, if we understand the contextual climate with the specific environment that we have in that particular area, so then we go for a combination of architectural approaches, engineering approaches, site planning, and also a landscaping, put everything together as a holistic approach to design the building. We talk about the new building, or we can also retrofit the existing building to meet this criteria. And we put the combination of passive and active devices to reach to the point that we want. So there is many tools as well. The most popular here in Malaysia may be the GBI tools. We have also BRIM tools. We have also CIDB MyCrest tools. We have also JKR Penarapan Hijau tools. We have also, for example, LEEDS tools. I think many. Some of the tools actually very, very important. We can use it either voluntary or by having our own what we call the initiative to our building which operate under us to use that kind of tools to measure what is things that can be contributed using this kind of tools regarding the energy efficiency and also the all those passive design strategies. So we need to employ the combination. Of course, the passive design cannot stand alone. They cannot just be there passively. It's still not sufficient for us to make it comfortable for us. So that is why the active devices need to be added on. But we understand what is actually the contextual to use it so that we can have it wisely, and then the operationally and the effective of the devices are there. For example, adopting mixed mode system, for example, optimize daylight and thermal comfort while reducing solar heat gain will be a strategy to achieve energy efficiency. So solar heat gain also things comes together with the natural light. And it comes together with the daylight. So how we want to remove the solar heat from the natural light? So there is measures to be there. There is strategies to add on so that we can reach to that. Because we want that light intensity as close to whatever that permissible and requirement. But at the same time, we want to try to remove the heat that comes together with that light. So the idea and the approaches need to be very coherent so that we can have it simultaneously both together. Okay. Basically, the basic approach towards good passive and design is oriented. First of all, of course, we talk about the building orientation, how to orientate the building nicely according to the sun path. We will look into the sun path later. And we need also to put a landscape on the shading, on how we want to shade it. Even with vegetation or maybe sort of architectural devices or architectural finish or architectural facade to insulate also. Insulation for us, for the wall panel, I can see there is not much practice here, but on the roof, there's insulation that we always put in the roof to ventilate and also to daylight or to daylight a building. So basic approach, first of all, orientate. We put a shade through the landscaping. We insulate, we ventilate, and we daylight the building. So this is about 5 approaches just to reach to whatever comfort that we want according to the basic requirement or basic criteria. Building have a primary function to provide an internal environment suitable for the purpose of the building. Of course, they need to be the first step where the building is designed to meet what is actually the purpose of the building. For example, the hotel room will be different from the sports center, for example. So the purpose need to be understood first so that we can put in our passive design strategies according to the what purpose of the building to be developed or constructed. The architectural passive design consideration: design of building is primarily influenced by the responsiveness to the site context that we're talking about just now. What is actually the context of that particular area? The important factors that should be considered include the site planning and orientation, or how we want to plan and orientate the building, in and out. Where is the landscape to be add on? Building orientation, facing to which? Where is the fascia? Where is the front? Front face of the building, what we call that, the facade of the building, for example, and how we want to put a daylight in. How we want to put the daylight inside the building. The facade design, not only for beautiful or to beautify the building, it also need to be functional in terms of this passive design strategies. Natural ventilation, we put everything inside so that they can be function as a living building. Building need to be what we call it, tackle as of living things. They're also a new concept. While we don't want to just a casted building where there is no emotional feeling at all, we need to make it live. So once it's living, so we can have a coherent communication between living people and living buildings. So we don't want to communicate within living people to the dead building, for example. So things like that now become a good approaches in many countries where they are talking about building need to be considered as living things as well. So thermal insulation, strategic landscape, and also RE we have to put in. But we don't want to focus on RE in this topic today because we want to talk about the energy efficiency only lah. These factors are just an important selection of active system or devices to control visual and thermal comfort within the building, and not to impose any significant cost. Some of the approaches don't impose any cost. Not impose any cost. So we just need to understand how it behaves and implement it in our building. Okay, I think this is so familiar with all of us. We're talking about the sun path diagram. Here, particularly in Kuala Lumpur, latitude and longitude is there. This is how the sun is actually movement above our head every day. So we are now in May. So sun path will be somewhere on the north side. Somewhere on the north side. This is north south. So somewhere on the north side, and it will be reached to the maximum on farthest north in June, and come back July, August, September to the other position, and end up in December at the farthest farthest south. So this is how the sun is actually movement from. This is our globe. Basically, sun is coming from direction that not at the same east every day. Not the same east location every day. They will moving. We can see sun is actually moving here and there, here and there, here and there, come and go, come and go. That's why we have our equinox every 2 times every year. Equinox means that the sun is actually on top of our building, on our head. So this is where it happened on 1st April here, and also somewhere in September. Somewhere in September, this line. 1st April, about 31st May and March, or 1st April, something over there. Here, we are here. And also somewhere in September. So 2 times equinox happening in Malaysia, and also all climatic conditions also having the same chance to have that kind of situation. So this sun path diagram showing us is actually understand the sun path diagram. Of course, we can change our building, but to put it in a very optimized location so that we can have it nicely communicate with the sun direction or sun distribution. So there is more interesting pictures to see about this here. The same pictures is taking from the same angle, different months. So you can see actually the sun is moving. Of course, they're moving come back to the original position, and they start again January, December to January, December, January. So things like this is actually happening without we realize. Sometimes we don't realize it. So for those who are in this field, research, or you're talking about building strategies on all those passive design, for example, you are environmentalists, you will notice. But most of us is not noticing anything. They just know that sun is there every morning, 7:30, and will be disappear at 7:30 at the evening. So things we need to change it so that we can appreciate more what's actually around us, so that we can make it use as our strategies in terms of our work too lah. Okay, so this is very, very important to understand how we want to orientate the building based on this kind of sun movement. And passive design strategies also talking about these areas. I don't want to read everything, but I have actually explained few of them. We're talking about the insulation, we're talking about the cross ventilation, we're talking about good ventilation, we're talking about the vegetation, we're talking about the landscaping, we're talking about human activities, we're talking about how the heat can be dissipated through the opening. We're talking about this is regarding the most likely talking about the air change only lah. Okay. Here again, we talk about equinox on 31st March and also September 23rd. We're talking about this where the sun is actually movement, and our location here on the earth, on the Jan. So there is a way where we are so close to the sun, about 147 million kilometers, and there is a time also we are far from the sun, it's about 152 million kilometers. So that also create another understanding. We can have a very hot season and cool season for our climatic, and for those who are living in the four seasons areas, so they will be experience more varieties in terms of their what we call that environment due to this sun and also earth positioning. Okay, while we understand it, so we know that here in Malaysia, this is how our sun path looks like. For those who are in the UK, the sun is actually on the south, because sun is actually there, the south. For those who are in New Zealand, the sun is actually on the north side. So facing it, orientate the building based on this climatic condition. It will be based on actually where is the sun position on our globe. So that is where the understanding on the sun positioning is very, very important. So that not only us actually, the trees, pokok, also we're looking for the sun too. So they will go straight. Right? If you involve in the what you call that, the landscaping, you will know. Actually, the trees also looking for the sun rays to make it. So same goes to human. So now understand it, and we'll try to make it, impose it in our future design, so that we can understand it's actually what is we are talking about here. And of course, this is not from here because they got winter and summer, but the thing is how they orientate the building based on this condition to understand what is the location of the sun during that time, so that we can make the things happen. So ancient civilization also much refers to the sun movement, not only sun movement, so they understand how to put things, particularly they can get a very good time to work on it. Okay, not only sun, we are not talking about heat. The sun also influence on the global wind, because wind is actually originated from the heat and cool area. Heating, cooling, both will create this what we call that, the global wind. So the rotation of the earth, okay, we read from the top. The sun powers the wind by heating up parts of the earth more than others. Wind is the movement of air. The sun heat the air, and the warm air rises. The rising warm, blah, blah, blah. Okay, the causes of the global wind is, first of all, the rotation of the earth, distribution of continents and oceans, and even heating of earth's surface of sun, and also differences in atmospheric pressures. So the winds, movement also depend on the sun, intensity on the sun. So basically, sun is the sun is actually the cost of living. Everything is actually referring to the sun to make sure things like this happen in our earth, on our earth. So the cross ventilation, one approaches. So I understand the wind. Some of the place also, they have a very consistent wind flow. So they can make use of wind turbine in that area because they have a consistent wind flow. Normally on the south side, on the north side, and also the south side, where they have very consistent flow on the uniform direction throughout the year. For us in the equatorial side, you can see our wind is actually goes everywhere and coming everywhere, coming from the top, coming also from the north. So that is why the what we call it, the wind turbine is not popular here in Asia. So some other places, they have very one unidirectional of the wind flow. So that is where they can put the wind turbine over there. So we understand. While we understand, so now we can make it as an advantage of our design too. Cross ventilation, how we can invite the wind from one direction and show the right or show the way for the wind to flow on the another direction. These are two things that can come into the passive design strategies, from the stack ventilation from the lower inlet into the higher inlet, to understand how it can be passing through our buildings or our rooms, and some of the air movement, what we call that, impact on our sensational. For example, we have air speed below than 0.25. So this is the effect and also the sensation that we can sense. I don't want also to read everything, but you can have this slide later. I got about 15 minutes to go. Strategic landscaping. We're talking about how we want to involve the landscape inside our design and in our either new building or new construction or retrofitting building, on how we can put in the landscape influence into to mix up with the building. So just like I said, building need to be uh, treated as a living things. So we want it to blend and to interact with their environment. So the environment need to be there to interact with the building. So we're talking about the building, what we call it, landscaping and all those kind of passive strategies. At the same time, we add on the passive design strategies to put in more in terms of the efficiency of the buildings. Okay, so wait. Okay. Knowing of the direction of wind circulation and the path at specific location. So design within the contextual climate and site is the first step to optimize the benefits provided by the specific environment. This was mentioned before. And a combined architectural, engineering, site planning, and landscape holistic approach will optimize the energy efficiency of the building, especially when employ combined passive and active devices. This is what we call a sustainable design approaches, where some of it will be also influenced into the ESG related to what theme that we have today. Passive design strategies plus active devices, we can have that sustainable buildings in our at our place. So understanding the overall science behind the building science or environmental science will assist us to create a better building, better building conditions, to add more what we call that, strategies to uh, to make it efficient for our daily use. Okay, sunlight. These are some strategies related to how we want to control the lights. Remember, light from the outside, the daylight is very, very important for inside, for interior of the building. It comes with the three main components. They are the light intensity, talking about the lux. There is actually the solar radiation, talking about the radiation in terms of illuminance level, watt per meter square. And also there is a heat also coming together. So we don't want these two. We just want the light. On how to remove these two, there's many strategies. One of it is to use the light shaft to bounce the light from outside to make it more, things like stable, not directly there. we can also invite light through the skylights, invite light through the skylight. But of course, we need to have a good, what we call that, infra to remove the heat, to remove the heat. There is a possibility to remove the heat from the skylight directly. But some of the countries, they might invite the light straight away from here because they are not just like our country. So their countries, the highest temperature maybe about 22, 23, 24. So they can invite the direct sunlight inside the buildings. But for our countries, cannot be done that way. And light well, also one of the strategies where we can invite the light through the light well from the top through the interior of the building. We have also a sawtooth roof. So that sawtooth roof is very popular in the north hemisphere and also south hemisphere because the sun is actually moving from the south or even the north side. So this is shown by the pictures here just now, talking about the location where I share here on the UK side, for example, and also from the New Zealand side, for example. So the sawtooth roof is very, very popular over there. Popular because this is things that can be invite the light through this kind of roof setup. But it's not popular here in Malaysia. It's not popular here in Malaysia. Even though there's also construction is using this, they just invite the light coming from the sky. Okay, we can have a roof monitor. A roof monitor is very popular. We have this many in Malaysia, very popular. We have also an atrium. Atrium also strategies to invite the daylighting inside the building through the passive strategies. It's part of the passive strategies too. But again, when we talk about atrium, there will be another components coming together with the what we call it, with the light, which is the solar radiation and also the heat. So how we want to control it in terms of getting the wanted what we want from the light intensity, but we don't want the heat and also the solar radiation. So things like that actually can be explored. Okay, this is actually a solar forgot the name, solar tube. Is it solar tube? Yeah, solar tube. Solar tube where they have a dome glass outside the building, and we have the tubing and to diffuse the light inside the building like this, for example. So this is the outdoor dome, and there's a reflective what we call it, tubing inside it, and it will reflect inside the building. So these strategies also can be used because definitely we will cut off the heat because actually coming through the tube. So things we have this. I've made this project. I think last about 8 years ago at Plus Highway. Plus Highway, not the highway, of course, the office building. So we invite this kind of technologies just to bring the light into the area where we need sunlight while we don't have the opening, talking about windows and doors. So to make it inside the building, this is thing that can be done too. But with some limitation, of course. But it's good technology to be explored. And a solar tube just now. This is the same thing. This is solar tube. This is a solar tube. Consists of small glass or plastic dome shape mounted on the roof of the collect sun, and there is a polished aluminum tube extend from the roof to the ceiling. Solar tube skylight lets a lot of light from rather small opening, much smaller than skylight standards, thus reducing the amount of heat. So be aware on the how we want to deal with the heat and also the solar radiations, because we can invite the light, but of course it comes with the other components too. So this is an example on how it can be very, very useful, especially where the location of the room that we want to illuminate is far or the middle of the building, where cannot reach by any of the building envelope directions. Solar lighting.
Arkam, we are sorry, you have 1 minute.
Okay. I want to finish now. Thank you. And also the comprehensive approaches on how we can go for building maintenance or building what you call it, efficient monitoring by having all those system and technology inside our building. So here, I think the last one will be the slide for you to download. Is there any more else? Okay, I'll put it pause there so that you can have few minutes to download the slides. It's usually there, maybe about half minutes. Okay, just to conclude before we end the session, uh, a passive design strategy is actually part of the very useful approaches when talking about passive. We're talking about the implementing the ESG inside the building. So what we want to know is actually to encourage the design, construction, operate, and maintain of the new or maybe the existing buildings, and maybe reduce the use of energy without constraining creativity. We don't want our building to be very plain. There is no elements of arts at all. We don't want to constrain the creativity. Just to put materials as a building material as one of the important parts, and we have the mindset of energy efficiency in the sense to confer productivity of the occupants and appropriately dealing with the cost consideration, provide the criteria and minimum standards, provide guidance for energy efficiency design, and also encourage the application of renewable energy in new and existing buildings to minimize reliance on the non-renewable energy sources. So with that note, I think I can end the session. I can end the talk. Again, I would like to thank to our organizer, especially Mafam for inviting me, and also Encik Shah tadi. Thank you so much. And all participants who are dealing with our program today.